Hello, in this video I would like to show you how to use the disk method to find the volume of solid region obtained by revolving some region about the x-axis or the y-axis. Okay, so let's consider the following example. Let's consider the function y equal to psi of x on the interval 0 to pi. Okay, and then let me graph this function. Okay, here's 0 to pi, and then pi over 2, here's 1. At pi over 2, the function is 1, we know that. So all of us should know the graph of psi, right, on 0 to pi. So we have some region, enclosed by the graph of this function, the x-axis, and on the interval 0 to pi. Now we have some region, let's say the region R, right? And now we rotate R about the x-axis, we get some solid region. So we get something like this. Okay, that is solid region. So it looks like a ball, right? And we need to find the volume of that ball. Find the volume of the solid region formed by rotating R, the region R, about the x-axis. Okay, so now let's talk about the idea how to find the volume. The main idea in integration is, firstly, we need to split our object into small pieces. Secondly, we approximate each small piece by some well-known figure, right? Thirdly, we sum them up and we get some Riemann sum. And then we do some limit process. By doing so, we have some integral. We did that a lot when we study area of regions, right? Let's repeat that idea, right, for this picture. So in this situation, I rotate our region about the x-axis. So I would like to approximate, first I divide our solid region in small pieces like this, okay? And here, suppose that is delta x, and here, we can say that is xi. In here and here, I have f of xi. Okay, so for this small piece, let me zoom that out, okay? So for this small piece, I will approximate, x volume by the volume of some disk, So I have something like this, some disk like this, okay? Some disk like this. So basically, I will have the following disk, in another interval. So I have something like this. Yes. And in here, we have something like this. So you can imagine about the disk, right? Okay, so now I will find the volume of each small disk in here. So what is the volume of the disk? Let's zoom out. Let's zoom out the disk, right? The disk look like this, right? So this is our disk. So this is the height. The height in this situation equal to delta x. You see, delta x is in here. Here's the height. And then we need to find the area of the base, right? So the area of the base is equal to pi radius square. Area of the base equal to pi radius square. What is the radius in this situation? So see, here's the radius. Since this is the disk and the radius is, the function value, this is the radius. So this radius equal to f of xi. Okay. So we're writing here the area of the base is equal to pi f of xi square. From here, we can find the volume of each disk of the disk. The volume of the disk is equal to pi f of xi square times delta x. So see, we have something already, right? So we have, that is the volume of each disk, and we use this to approximate each small piece of our solid region. And now I will sum them up. Okay, I will get some Riemann sum. I get some Riemann sum. So that Riemann sum is equal to sum from 1 to n pi f of xi squared delta x. You see, we have sum from 1 to n because, you know, we split the interval 0 to pi into n subintervals, let's say of the same width, delta x. And then we will consider some limit process. And finally, I will get the exact volume of our solid region. So the volume of a solid is equal to, so here's the trick, right? This is sum, we'll go to integral from 0 to pi, or basically I can write from a to b, right? And here, the number pi, that is just number. I will print that out of the integral. I have pi in here, okay? And f of xi square will go to f of x square, and then delta x will go to dx. So basically, we already have the formula of the volume of our solid region, and this is the formula. So if they give you a function f of x, right, and then we say, yeah, we rotate some region about the x-axis, we just apply this formula to find the volume. All right, so let's solve our problem. In this case, our problem is y equal to psi of x, okay? So I just substitute f of x into this formula. So I write volume is equal to pi integral from 0 to pi psi square of x dx, right? And now we have to remove squaring here. You know, we have the following formula. Cosine of 2x equal to 1 minus 2 psi square of x. So that means, you know, you can solve for psi square. You get psi square of x is equal to 1 minus cosine of 2x over 2, okay? So I will substitute this into the formula. I have, this is just pi integral from 0 to pi. Psi square is 1 minus cosine of 2x over 2 dx, okay? I have this just pi from 0 to pi, 1/2 minus cosine of 2x over 2 dx. And then we can split this integral into two integrals. The first one is pi from 0 to pi, 1/2 dx. The second one is pi 0 to pi. I can write in here over 2 cosine of 2x dx. You know, over 2 because cosine of 2x over 2. So I bring over 2 out. I want over 2 out. So the first integral is easy. This is equal to pi times 1/2 times pi, right? The second one, pi over 2. And then what is antiderivative of cosine 2x? Antiderivative of cosine of 2x. So if you don't remember the formula, you can do substitution, right? But basically, you know, you have formula sheet with you. That is just 1/2 psi of 2x plus c, right? Plus c. So I applied this function for this integral, I have power 2 times, 1 over 2 sub 2x evaluated from 0 to pi. So basically, for this term, when you plug pi and 0 into this, you get 0. Why? Because that is just, pi over 4 minus pi over 4 in here, and then sine of 2 pi minus sine of 0. Both numbers are just 0. So the final answer is pi squared over 2. And that is the volume of our solid region. Go back to this. And the volume of this guy is equal to pi over 2, pi squared over 2. So you see, it's not really difficult, right, with this method. And we need to pay attention. If you rotate some region about the x-axis, okay, so it would be easier to use this method to find the volume of our solid region. Let's consider the following example. Let's consider one more, and then we finish this topic, okay? Example 2. Now our function is y equal to 1 over 1 plus x squared, right? Let's take square root in here. And we consider function on the interval -1 to 1, okay? We need to find the volume. Of the solid region. Formed by revolving the region and closed by the graph of this function. Okay. The y equal to 0. And the y equal to 0, I can write in short in here. Just we consider interval, -1 to 1, okay? So let's graph this function. You see, in such situation, I really don't need the exact graph. I just want to make sure if the graph is above or on the x-axis, or there is any x-intercept of this function. So I just graph that very briefly. Here is y, here's x, here's 1, -1 in here and 1 in here, 0 in here, and here's 1. The function is equal to 1 over square root of 2 at -1 and 1. So I have these 2 parts, right? When x equal to 0, the function is 1. I just plug 0 into the function, I get 1. So basically the graph looks like this. Something like that, something like that. Okay, here is our region. This is our region. And we rotate this region about the x-axis. Okay, we rotate about the x-axis, we get some solid region. So our solid region looks like this, something like this. Yeah, in here, and then this is 1, so I get something like this. Yes, and we need to find the volume of this solid region. Okay, now let's use this method, right? So in order to use this method, I will make a cut. This is my cut. Okay, and this is delta x. Okay, of course the radius is equal to f of x, right? Because this is f of x. So now we can write the formula. The volume is equal to pi integral from -1 to 1 f of x squared dx. We have to be careful in this situation, because basically from the previous example, we have f of x squared in here, right? But in general, we would write, yeah, that is a radius square. So in this situation, we rotate our region about the x-axis. So the radius is equal to f of x. But if we rotate about another axis, the radius may not be f of x. So be careful with that. So that's why each time I try to write, yeah, the radius is equal to f of x, because we need to find, the volume of the disk, right? And we need radius. All right, so now we just plug our function into this integral formula. I get pi integral from -1 to 1 over square root of x squared plus 1 dx. Here, everything square. And square root will be cancelled out. I get pi -1 to 1, and then dx over x squared plus 1. And this is very familiar integral formula for us, right? Dx over x squared plus 1. So what is that? That is, arctangent of x, right? So I write here pi arctangent of x evaluated from -1 to 1, which is equal to pi arctangent of 1 minus arctangent of -1. And I know arctangent of 1 is pi over 4, right? This is pi over 4 minus. This is negative pi over 4. So I have minus negative pi over 4. Everything multiplied with pi. So I have pi in here. I have pi over 2. Overall, I get pi squared over 2. Okay, so I hope that this video is useful for you and would help you to study better in Calculus 2. Thank you.